this little box traveled into space, and it came back. Since 2017, Israeli startup SpacePharma has already sent 4 other mini laboratories into orbit, which have made it possible to conduct hundreds of experiments in a weightless environment.
Microgravity is the most extreme environment for life. There's nothing on Earth that resembles the space. When we send chemical and biological experiments to space, we learn new things on us, on our health and on our body that we cannot learn on Earth. We are making experiments that are impossible to perform on Earth, and then we find new phenomena and also new ways to develop better drugs and to improve our health.
But before they could conduct experiments, they had to achieve a technological feat: miniaturize all the tools found in a laboratory.
This is a whole laboratory squeezed into a very small box. It has everything that the researchers need to make a very elaborate experiment. We have a refrigerator where we store the material and the product. We have pumps that flow the liquids into the reactor. The reactor is here. And we also have here an analytical unit that includes a microscope and some measurement device that can measure the reaction and send the results directly to Earth.
The experiments are directed entirely and remotely from Earth, while the Nano satellite containing the laboratory orbits 326 miles above our heads.
This is the control room. From here we will control communication with the satellite. Right now we are connected to the previous satellite that we have, Dido 2, which is still in orbit. On the left screen we see the interface with the experiments itself. This is the screen where we upload commands to the satellite. In the middle screen, we can see the data about the satellite itself, its position, its charging situation, etc. And in the right screen, you can see a few of the recent pictures we have downloaded from it. And these are pictures that are taken by the microscope, which is on board the satellite.
This week, the Ariane 5 rocket is scheduled to lift off from Kourou in French Guiana with one of these mini laboratories on board, as part of an Israeli-Italian joint project.
It's going to have 2 solar panels which are going to deploy. Everything must be squeezed, shrinked to fit in order to reduce the cost of the launch. The launcher, by the way, it stalls like, I think, 63 meters long. It's very tall. And within it, there is something very little, very light, that can do tremendous things in it.
The laboratory, which maintains a temperature equal to that of the human body, will make it possible to conduct experiments on the aging of neurons, resistance of bacteria to antibiotics, and how to improve the absorption capacity of medication.
We are a small country, but we have a long history in space. The first Israeli satellite was launched in '88. Actually, we were the 8th country in the world that had the entire capability in space, which means we can design a satellite, we can operate satellite, and we can launch satellite. The importance of doing experiment in microgravity, it's open a new era, but in the near future, materials will be manufactured in space, and you have to do experiment in order to test that.
With the ability to conduct such experiments, these laboratories in space are taking the next step to prepare for manned missions on the Moon, Mars, and possibly even boldly go where no one has gone before.